Hello, my dear friends. So, welcome back to our lecture series on gravitation. And in this series, the next lecture which we're going to discuss is on the topic mass and weight. And we will also prove that weight on moon is equal to 1 by 6th of weight on earth. Okay, which we discussed in last lecture that whenever we go to moon, our weight becomes 1 by 6th of the weight on earth. However, it is looking as it is, if it is not possible, but it is actually possible. So what is that which do not changes? Today we will going to discuss, right? Okay. So first, what is mass? Okay, when you go to moon, right? As in last lecture, I told you that when you go to moon, your weight will get decreased, and there will be something which will not get decreased. Let us suppose I give example. This is a pen, right? And we measure its weight here by putting it on a weighing machine. And if the machine shows it is, say, for example, 12 gram, right? Now I go to moon. However, it's not so simple to go to moon that but let us imagine that we are going to moon. Now we are going to moon with the weighing machine and this pen also, which we measured here on earth. This is the weight on earth. I'm giving just one example only. Now we go to moon and we took the same scale, same weighing machine and same pen with us. And then on the moon surface, we put the weighing machine and we measured its weight. This shows the weight of this pen, weight on moon for this pen is 2 grams, right? It is sure. If you will go, you can check. But do you think that when you went to moon, does the plastic, ink, or anything which is there, mean the quantity of matter, quantity of whole matter, plastic, ink, and this ink pad or whatever it is containing is contained in the pen, does it changes? No, quantity of matter remains same. This quantity of matter is what? This is called mass. So this quantity of matter which do not changes wherever you go is called as mass. It is not mass. Mass is flesh. That is different thing, right? It is mass, mass. So it is the quantity of matter contained in the body. Like if you take example of this body, so this thing, this plastic, rubber, everything, this is the quantity of matter. Whether you go to moon, whether you go to any planet, whether you go to center of earth, quantity of matter contained in this body will never change. That is constant. That has a constant value. And that quantity of matter contained in this body is called as mass. Right? So mass is, in simple terms, quantity of matter contained in the body. Now, what is weight? Okay, weight is nothing but the force. Which force? The force with which the bodies are attracted towards the center of earth. Like in the previous lecture, I showed you that when you throw this pen, you just leave this pen from your hand, it just go towards the earth. It means earth is pulling this pen downward, right? And when earth is pulling this downward, it means earth is exerting some sort of force on it. And that force with which this pen is going downward towards the earth, that force is called as weight of the body, right? So weight is nothing but force with which body is attracted towards center of earth. Is that okay? So did you understand the difference between mass and weight? Clearly, when you take example of this, you take it and measure it on the surface of earth. Let us say it is 12 gram. Take it on the moon, again measure it. It is 2 grams. Do you know what that 12 gram and 2 grams are what? They are the weight of this duster, not the mass. Because mass is not changed. The physical quantity contained in this body, plastic, rubber, pad, etc., this all is the quantity of matter. It will not change whether you go to moon or whether you stay on the surface of earth. So this is the mass, quantity of matter. It is always constant. And weight is the feeling of force. Which force? That force which attracts the body towards the center of earth, right? So this is the difference between weight and mass, because weight can have a zero value also. Do you know where the weight is zero? Where the weight is zero? Tell me. Weight is zero at the center of earth. If you go at the center of earth, acceleration due to gravity g is zero. Now, how this formula of weight we will derive? You know, this is earth, right? This is object. Its mass is m, right? It is pulled by the earth with a force, right? And when it is pulled down, the mass, mean this body, goes towards the earth with a speed, with a changing velocity, right? And whenever velocity changes, acceleration is produced. How much acceleration is produced? I told you, small g. So there is an acceleration, small g. The force is F, mass is m. Now, what is force actually? Mass into acceleration. But here it is not acceleration, acceleration due to gravity. Gravity is the force with which a body is attracted towards the earth, right? So F equals to mass is m and it is g. So the force with which this duster is being pulled by the earth is given by mg. But I told you in the beginning of the lecture that weight is what? Weight is the force with which the body is attracted towards the center of earth. It means this force is nothing, but actually it is weight. So this is weight W equals to mg. So this is the formula of weight. W is always equal to m into g. What is m? Mass of the body. What is g? Acceleration due to gravity. On the surface of earth, its value is constant, 9.8 meter per second square, but it changes at depth. If you go inside the earth, it will change. If you go just above the earth, it will change. If you go at the center of the earth, it will become zero. On the poles, on the equator, everywhere it changes. But on the surface of earth, on a general, its value is, acceleration due to gravity has a value of 9.8 meter per second square, right? I told you in previous lecture also with the complete detail, right? So now you are clear that weight is nothing but the force with which a body is attracted towards the center of earth, and that is given by m into g. Okay, is that clear to you? Okay. Now we will prove mathematically that weight of any object on the moon becomes 1 by 6th of the weight on earth. How we will prove? So let us say it is earth, mass is me, right? And this is the body of mass m. This is radius of earth. This is our moon. Mass is say mass of moon. This is nothing but rm, radius of moon. This is the same object whose weight is to be measured. Now there are two cases. In first case, case number 1, look, when you want to make the things interesting, when you want to learn the things quickly, when you want to go for numerical solutions, just make a diagram. Make a habit to make a diagram, so that when you make a diagram, things are quite clear to you. Now in this diagram, case 1, the object is on the surface of Earth. Mean we have put an object on the surface of Earth. We want to measure its weight using a weighing machine. RE is the radius of Earth, ME is the mass of Earth. Now we took this weighing machine and the object both to the moon using some satellite, and then the mass will remain same. I told you mass is constant, mass will remain same. Rm is the radius of moon, mm is the radius of mass of moon. So let us define the things, case 1, case 2. So in case 1, let Re equal to radius of Earth, Me mass of Earth, small m mass of object about whom we are talking, that object will weigh less or more on moon, that we have to check. And in case number 2, we assume that mm is equal to mass of moon, Rm equals to radius of moon, and small m equals to mass of object, because mass do not changes whether you go to moon, whether you stay on the Earth. I told you. So now we will solve whether weight changes or not. Let us see. So in case number 1, what will be the force between these two? According to Newton's universal law of gravitation. What is Newton's universal law of gravitation? F equals to G m1 m2 upon r square. If there are two bodies and there is a force of attraction between these two bodies, that force is given by this formula, where G is universal gravitation constant. I told you many times. M1, M2 are the masses of first body and the second body. R is the distance between the two bodies, right? So we will use this formula here. We will find the force between this and this, mean body and the earth, right? So capital G, M1 is M, M2 is Me upon RE square. But I told you, this force is nothing but weight. So weight of body on earth equals to G M. Okay, we take, this is force, right? So we take as weight equal to weight on earth equals to G M Me upon RE square. Okay, this is one thing we have find out. Now in this case, we will find the force between this object and the moon. Capital G, first body mass M, second body mass capital mm, divided by distance between them Rm square. This is nothing but weight on moon. Weight on moon equals to G M divided by Rm square, right? So this is weight on moon. Let us divide this by this. So weight on moon divided by weight on earth equals to, weight on moon, how much? G M upon Rm square divided by weight on earth, this one, G M E M upon R E square. So weight on moon upon weight on earth equals to, you know that what will happen, G M M upon R M square R E square divided by G M E M. G cancel, M cancel. So weight on moon upon weight on earth equals to M R E square upon R M square M E. Now you know the data. You know what is radius of earth, 6.4 into 10 to power 6 meter. You know what is the mass of earth, 6 into 10 to power 24 kilogram. Just you have to remember two things only, mass of moon and radius of moon, that you can take from the book. That is very easy, just remember it. Put these values and solve. You will see that weight on moon divided by weight on earth equals to, all this after cutting will come out to be nearly equal to 1 by 6th. So weight on moon equal to 1 by 6th time weight on earth. Miracle. We have proved that on the moon weight is 1 by 6th of the weight on earth. You will say, where this 1 by 6 come from? I told you. You know the value of RE, put the value here. Put the value of ME, put the value of radius of moon, put the value of MM, and simplify it. It is nearly equal to 1 by 6th. I have done it. It's a pretty simple and somewhat long calculation, but you can do it very easily. Right? It will come out to be 1 by 6. So we have proved that weight of any object on the moon is 1 by 6th of the weight on earth. What does not changes actually? What is the thing which not changes? That is mass. What changes only? That is weight. So this is the difference between mass and weight. And there is one place on the earth where your weight will be 0. What is that? Center of earth. Always remember, because on center of earth small g equals to 0, and you know that weight equal to mg. If g is 0, weight will be 0, because mass can never be 0. Mass can never be 0. Always remember, mass is the quantity. How you can send it to 0? No, it is not possible. So that's why weight of any body can change according to the place. But place doesn't mean that whether you go to Dubai or America, your weight will change. No. At some specific places on the Earth's surface or in the inside Earth's surface or on other planets, that's all. So mass is the quantity which do not changes, that is always constant. So I think all these things are clear to you, and so bye bye, and we will meet you in the next lecture in the same series of gravitation unit. And till then, I would again request you to please subscribe to my channel if you are new, and press the bell button so that you can get the notification of the new video posted. And please also share it to your friend circle so that knowledge can flow from you to them also. Thank you very much.